Welcome back, students. We're moving into Lesson 6. This is Video 6A. The main topic of Lesson 6 is experimental design. If you think back to Lesson 5, we were looking at observational studies and we were looking at different methods of taking surveys and sampling. So we may have said that that was a hands-off way to collect data. Now we're going to move into more manipulation and actually running design experiments. Okay. So we'll lead this off with an example. A few years ago, back in spring of 2011, our developmental math sequence at Cecil College was redesigned. These are the classes Math 91, Math 92, and Math 93. Okay. The reason that the math department did a redesign was in attempts to help increase the completion rate. Long ago, the completion rates were on the low side, so the math department decided to take some action, make some positive steps, and see what happened to the pass rates. Okay, so diagram the experiment. I'm going to go over here to the sideboard, and I'd just like to write down some notes. When we're doing a designed experiment, basically as a researcher or statistician, we are manipulating some factors in attempts to change the outcome. Okay, so before the math redesign, let's think about how the developmental math classes were run. For one, we had separate rooms. So Math 91, 92, and 93 were all in separate rooms. Before, the class sizes were smaller. Before, there may have been a lecture component as well as a computerized component. So I'll write that as possible. Sort of depended which class you may have been in and your instructor, but there was a possible lecture portion to the class. So we had separate rooms, class sizes were smaller, possible lecture components, and before, like I was saying, the pass rate's not so hot. Percentage of students passing, pass rates, oh, we'll just say low. We'll call it what it is. Okay, so the math department said, what can we change? We'll put that as after here. And whenever you're running a designed experiment or sort of a pseudo-designed experiment, you're making changes to some factors to see what happens. And obviously we'd like the pass rates of our classes to be higher. Okay, first thing that happened, the classes were combined, right? So after everybody in the same room. Everyone in the same room. So developmental math, 91, 92, 93, all in the same room. Sort of an effect of that is that while class sizes used to be smaller and now class sizes are actually much larger. So we're making changes here. We're going to see what happens. What else? The lecture component was essentially eliminated. So almost the entire class is now computerized, as opposed to an instructor lecturing material. And essentially, it's more self-paced than it used to be. Other things may have changed. In a nutshell, here are some of the main bullet points. We sort of ran out of room here on the board, so we'll stop it at this. And after we made the changes, we would like to see what happened to the pass rates, right? So I'll just leave that as an open-ended question here. What would we measure? We would measure the percentage of students who were passing the class, right? So what happened to the pass rates? If you think about this way of collecting data as opposed to just taking a simple random sample or finding some information on the internet, this is very different than what we did in Lesson 5. I think I called Lesson 5 stuff maybe hands-off. Sometimes I've said in class a designed experiment. This is more of a hands-on way of collecting data because as a researcher you are changing things to see what happens. Okay, so I think there's some fill in the blanks over on the projector here. What I'll do, we'll get all these on the page and then we'll relate it back to the example at the end. So, main points of this Lesson 6, designed experiments. Well, sort of an easy one. For the most part, we need to run a designed experiment if we want to collect evidence needed to show cause and effect. For the most part, we need to run a designed experiment. Observational studies, this was Lesson 5, will not, in almost every case. There's always exceptions. But in general, observational studies will not provide us with enough evidence to show cause and effect. Okay, if we want to go to that next step, this is a stronger relationship, then we typically will need to run a designed experiment. All right, next one. Main points. By actively manipulating treatments applied to the experimental units. Manipulation. By actively manipulating the treatments applied to the experimental units, we can build a case that a certain treatment leads to a certain outcome. This is sort of the main point of running an experiment. Okay? Good experimental design requires us to control sources of variation other than the factor that we're actually testing. Okay? What you have to think about is think about all the things that might affect the results of your experiment. What might affect pass rates in a developmental math class? It's over here, we won't move the camera, but we looked at class size and we looked at the delivery method of the contents, among other things. But those aren't the only things that would affect pass rates, right? When you're running experimental design, you need to plan ahead. You need to think about all the things that might affect pass rates and try to control for them, okay? So, those are the next two. We'll flip the slide here. Don't write manipulation here. Let's get that out of there. Next bullet point, main point. Something allows us to equalize the effects of unknown sources of variation. We must randomize the treatments when running an experiment. Well, sort of gave that one away here. Randomization. Randomization is the key to running a designed experiment. You have to randomize your treatments, okay? And we'll talk about that when we wrap up this video. Down at the bottom here, multiple runs of a treatment on an experimental unit is a good thing. We like lots of data, so multiple runs, we would like to run our experiment on multiple people, multiple experimental units. This gives us confidence in our conclusions, and this is called replication. Multiple runs of a treatment on an experimental unit is a good thing, and that's called replication. All right, I'm peeking at my notes here. Looks like there's just a few more. And here will be the second to last one, main points. At times, another variable might influence the results of our experiment. We just don't happen to be studying its effects. We can utilize what's called blocking to remove this added variable. For now, students, just get this word on the blank. It won't relate precisely to the developmental math example that we'll wrap up with, but when we get to a second example in the next video, then we'll talk more about blocking. Okay, last one. When you're running a design experiment, at times, what's called a confounding variable. Whoops. I guess just confounding because we got variable there. At times, a confounding variable might be the real reason for the results that we are seeing. So you run a nice watertight designed experiment, you get nice clean results, you think you've really got something, and then all of a sudden it was something you didn't even think about in the background that's really causing the results that you're seeing. That'd be a confounding variable. Always be aware that there are other factors we may not have even considered. Just because you run a design experiment does not mean that you have arrived at the absolute answer for all of Earth and all of eternity, right? Always think everything through. Okay, so if we go back to the math example, we'll look on the sideboard here. I'm going to grab my notes so I remember to hit all the bullet points. Here's my before side, how developmental math used to be run a few years ago. Here's my after side, how developmental math used to be run, or now is currently being run. So, main points, let's see. Actively manipulating treatments. So, to sort of summarize up here, remind us. Of course we have manipulation here, right? The math department changed a lot of things when it comes to how we delivered these classes. Here's the manipulation. Before, everybody was in separate rooms. If you were in beginning algebra versus intermediate, or arithmetic, excuse me, versus beginning algebra versus intermediate algebra. We changed that. That's the manipulation. Everybody's now in the same room. Class sizes used to be smaller. Now we're putting everybody in one big class. Again, that's the manipulation. The things that we're changing, that's the manipulation. Next bullet point down was all about control. Control means we try to make the classroom experience exactly the same for all students. It would be nice in an ideal world if I had the exact same instructors before to compare with the exact same instructors afterwards. Now, realistically, when you're teaching classes at a college, you cannot really control everything that you would want to. But when you're thinking about control, you're trying to make all of the students get the same experience in the after group, except for what we're changing. We're trying to pin down, are there things I can change to increase those pass rates? Okay, so maybe same instructors, maybe running the classes at the same time in the same classrooms. These are things that we would control. Same textbooks, for example, before and after. All right. Now, I'm not saying when we did the developmental math switch that we were able to control everything, and oftentimes when you run an experiment, you may not be able to control everything. But you strive to control as much as you can. The next bullet point down was randomization. Did we randomize the treatments? A little bit tricky here. Probably the ideal way in a perfect world, if I was going to run this experiment, say I have 200 students that sign up for developmental math, I might flip coins at the beginning of a semester, and heads, you'll be running your class during the old way here, using the old methods. And if tails came up, I'll use the new methods. This would be a true randomization. Now, if we can assume that all the students that took math 91, 92, 93 were a representative sample of the typical Cecil students, and going forward, I assume all my classes afterwards are very representative, then we didn't randomize, but we can still probably draw conclusions from the way that this was set up. You can see to do that true randomization, as a student, you don't even know what class you're going to be in until the first day. Really wouldn't work. But when we run other designed experiments, we will try for this sort of randomization here. Okay? Probably okay the way we did it, but it wouldn't be a true randomization. All right, moving down the list, replication. Did I have replication? Many, many, many classes, many, many students to figure out pass rates. Lots of replication the old way. Going forward, starting in spring 11, lots and lots of classes, lots and lots of students. That's the replication, right? Think to yourself, if I only looked at one class the old way and compared it to one class the new way, could I really conclude anything and be comfortable with the conclusion? Probably not, right? You could have just had a bad class here and a good class here. With replication, though, that starts to get washed out. With replication, we'll expect to have many good and bad classes the old way and many good and bad classes the new way. All right. Blocking, we said we'll skip till the next video. And then finally, confounding variable. To answer the question, what happened to the pass rates, things have improved. There was a little bit of growing pains when we first switched over, but pass rates are on the rise gradually. Confounding variable, though. I've thought of one. I don't know that if this is really true or not, but I'll give it as an example. I was trying to think of something that may have affected the results, and I just made this up because I don't think it happened, but what if in the high schools, at precisely the time that we switched to the new methods, the high school math courses changed their curriculum or changed their textbook, and it just lined up perfectly with what we were doing at Cecil College? That's something in the background where really it wasn't the fact that students or our methods here to teach the classes are any different or help with the pass rates. It's that in the high schools, the students are coming to us better prepared. And it just happened at the exact point that we ran this experiment, right? This would be a confounding variable. We think it's us in the math department. Really, it was the high schools. Okay, so I believe that's the end of this video here. A little bit of introduction to designed experiments. And we'll see you next time real soon. Thanks for watching.